is the follow-up of the previous class on reflection of light by spherical mirrors. It is regarding the relative position of image with respect to object in case of concave mirror. This is the case number 1, where the object is placed between the point F and P. The point is focal point and P. And the object is kept between this point and this point. What would be the image formation? Let us have a discussion on this. You have to follow the similar techniques as we have followed in the previous session. The object is on the principal axis. The bottom is in touch with the principal axis. Let me take a point on the tip of the object and consider any two incidence rays. I am taking the incident ray. It is from the tip in the direction through the C, center of curvature. The incident ray selected in the direction of the point C, and after reflection it will be in the same line because this line is normal to the mirror. The incident ray and the reflected ray are in the same ray. This is what I have chosen from this point. And one more incident ray I am choosing. This is perpendicular. This is parallel to the principal axis. As you know, after the reflection, the reflected ray should pass through the F, the point of a focal point. So that is what the incident ray and the reflected ray, the direction. There is one more incident ray and the reflected ray, the same line. And these lines will never meet on this side. If they don't meet, you won't get the image at this side of the mirror. Then you look for extension of these rays. These are real ray, extend in the backward direction, that is a virtual ray. Extend them, the reflected ray and reflected ray, that is what extended in the backward direction. They will meet at this point, intersect at this point. This is the point of, what is the tip of the image. This should be the tip of the image. So the image at the point will be here, and remaining image should be drawn, should be perpendicular to the principal axis like this. So this is what the image we get for this object. It is kept in front of the concave mirror like this. What would be the nature of the image? Here the difference here, M stands for magnified. Image is magnified, greater than 1, and is always behind the mirror. And this image is vertical, that is erected and virtual. It is behind means virtual and erected. It means M is positive for this kind. So this M is positive means erected and virtual, the nature of the image. Magnified image you get. And the distances, when I talk about the U is the distance, there is the object distance from the point P. It is between the F and P and carries negative sign in this direction we are measuring. And the distance of the object from the point, it is positive behind the mirror, is the distance. positive, it is in the direction of measuring the distance. This is about the sign convention of UV, M, the value and as well as sign convention. Only in case like this, the remaining cases what we have discussed earlier, the 5 cases, in all such cases, we have now what is that the mirror gives real image and inverted, real and inverted. Only this is the case, it gives what is that erected and virtual by the concave mirror. These 6 cases we get from the concave mirror. Now let us understand what would be the relative position of the image with respect to object in case of convex lens. Here the surface is curved inward, surface is curved outward. This is the case. Let us understand the image formation in these cases. There are only 2 cases in this case. If we take the object at the infinite distance, this is the way of representation of taking the object at the infinite distance in front of the mirror. As you know, all the incident rays from the object near the mirror, they lie parallel to the principal axis. They remain parallel to the principal axis. And these incident rays, after the reflection, this would be the direction of reflection, and you see that this direction of reflection, all the direction, that is reflection, direction of all the reflected rays will pass through only this point, diverge at this point. F, this is F of the convex mirror. So any ray coming from the distance object, infinite distance, all of them are parallel from what is the point of different, from the points at different surface of the object. Look at that, parallel, and they diverge at this point. All of them diverge at this point. Then what would be the image? Even this point and this point getting coincided. You get a point. Image at the point size. Image is point size at F. Point size means magnification is 0. 0 magnification. Almost invisible point size at the point F. So image is at the point F positive in this direction. And distance of object is infinity minus in this direction. So this is symbols are, this is the P. This point is P of the mirror. So image formation is only at F when the object is at infinite distance and point size. All the lights merge into a point, that is diverge into a point. This is of course positive means it is a virtual and erected, but point size diminished, completely 0 diminution. This is one case. If the object is taken in front of the mirror at a finite distance, if the object is at a finite distance, that is some distance, what would be the image formation? Again, apply the same technique. This is on the line of principal axis in the vertical direction. Let me take the point, that is a point on the tip of the object from which any 2 incident rays, similar to all previous classes as we have discussed. I am taking one incident ray parallel to the principal axis. This is one. Another incident ray passing through the point C. This is the point center of curvature of convex mirror. This is the focal point of the convex mirror. After reflection, that is, if you take the incident ray in the direction of the point C, after reflection from the surface, it will remain the same line since it is normal to the mirror. Incident ray, reflected ray, same line. Incident ray, reflected ray in this direction. Look at the direction when you see at the backward, in the backward position, it is passing through the point F. This is usual notation. When a ray parallel to this principal axis will reflected in the direction passing through F, focal length of the mirror. This is a focal point of the mirror. So it looks like what is that? It is a divergent ray. It is what is that? Virtual ray backward. When they are extended, reflected ray and reflected ray of a reflection extended, they meet here. This should be the point of, that is, tip of the image, and remaining as drawing perpendicular to principal axis. This is the image formation. Looking at the differences between the image and the object, size, it is diminished. In this case, if the object is at a finite distance, any finite distance, the image is always what is that? Diminished, reduced. Diminished size is reduced to smaller size, and also it is virtual and acted behind the mirror. Virtual and acted. M carries positive sign. M carries positive sign. So that is the nature of M. And the distance of object is negative finite. Distance of image, it is positive. We are measuring in this direction, and it is always between P and F. Wherever the object is placed, that is at a finite distance, between infinity and P, finite distance, the image we always get at the point between P and F. That is an interesting point. Even if we change this, it is always between P and F, the image formation. Behind this virtual image and erected image, behind this mirror. This is the kind or nature of reflection by the convex mirror. In this case, the interesting point is this. This curved surface, outward surface, that is in the outward surface, due to this surface structure, it is outward surface, entire surface is curved outward. This surface will catch, or what is that? Will attract, will catch a very large number of incident rays. Due to this outward surface, it will catch very large number of incident rays from the larger area of the view. This is only case. This surface can, what is that, view or capture a very large area of view. Very large incident, large number of incidents it can catch from the surface. And that area, the entire area is viewed as image at the point, that is diminished image in between this and whatever the larger area, that is a fine field, wider field of view. It will capture wider field of view and seen as a diminished and erected image behind the mirror. That view, it is also similar to what is that just like panoramic view. Panoramic view. What is panoramic view? It is just like bird's eye view. Just like a bird which can view what is that entire area, that is large area from the eye. Panoramic view. Only this lens can produce us or gives a panoramic view of the field, a view, wider field of view. That is the basics of the convex mirror. Due to this nature, that is image, of course diminished and erected, that image gives the entire panoramic view towards which is faced. It is used in many applications. So many applications means we are using it, this convex mirror, as a rear view in vehicles, mirror, one case, and also as security mirror, because of wider area you can cover and you can view the entire area through the mirror. Security view in commercial establishments and ATMs. A security view in commercial shops and ATMs. That is another applications. And one more applications as traffic mirror. Traffic mirror at what is that, blind corners or blind curves to avoid collision between the vehicles. There you see the blind curves, they put some what is that convex mirror like this. Use a view. So in that case we are using it as a traffic mirror at the blind curve to avoid the collision between the vehicles. So because of this reason, what is that? Giving a panoramic view in front of this, we are seeing it as an entire area, of course a clarity, no break in the image, no break, and gives a entire as a large area, a clarity with the diminished area. That is why we can use this convex mirror in such cases. So with this we have finished the reflection of light by spherical surfaces and the relative position of the image with respect to the object. As the object varies, as the position of the object varies, how the image formation takes place in both the cases like concave mirror and convex mirror. With this you have finished this part of the syllabus. Thank you very much.